Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. Bacha, I am back again here with your remaining PU1 chapters, right? So we have not started PU1. I had some other commitments which had to be fulfilled. You had some requests that was made for your MCQ series, your Brahma series. So all of that was going on parallelly. So we have given the preference to the PU2 students. Yes, forgive me for that, but it was very necessary, bacha, because if you are somebody who is studying in PU2, you have exams coming up for boards and for KCET. That's why I completely focus my energy on the PU2. So I again MCQ series Decode NCERT will be carrying on as it is. I'm today starting again with your PU1 portions. Okay, so as you know, the chapters in PU1 are not high weighted chapters, but again it's very relevant to your boards because simple chapters are there. With simple formula based chapters are there. If you know these, means you can simply score 1 marks everywhere. Okay, means almost every chapter has 1 mark weightage. Okay, so 1 to 2 marks is coming from every chapter, so makes total of 14-15 marks from here. So why to miss out on that, right? Simple chapters are there, simple concepts are there, so we'll do all of them quickly, right? So again, bacha, in PU1 I'm starting today relation and functions. Okay, so this is a part 1 of relation and functions. In this session I'll discuss all the concepts, like we'll talk about relation, we'll talk about Cartesian product of sets, we'll talk about bacha your functions as well. So we'll see variety of functions, how we can define it. I'll show you the graphs as well. So all of that will be discussed in the session today, and we'll again solve some more than 10-15 questions. 10 to 12 questions I'll solve today in the session itself. Okay, so again then we'll do PYQs and everything, whatever you're doing as it is, practicing questions, PYQs, writing mocks, same will continue, right? So today's session will be only based upon one sort of your complete concept, with again 10 to 12 questions we'll solve in the session only. So I hope you're ready for that. I know I've seen your comments saying that, sir, when will you start PU1 series? So bacha, I'm here. As I said, I mentioned in your reply, I think I have not mentioned to every one of you, but I have, wherever I've mentioned that it's going to start very soon, and today's the day I'm starting your PU1 portions back. Okay, chaliye. So part 1, if you check bacha in relation and functions, okay, what we're gonna do, we'll talk about all the concepts first, then we'll, you know, the trend of my classes, talking over the concepts, then we move on and solve questions on them. That's how I do it, right? Whether it is 2 questions, 3 questions, 5 questions, 10 questions, but we'll certainly solve questions on the concept that we have learned on the day. Okay, so first thing is bacha, Cartesian product of a set. What we do over here, for any 2 given sets, it has to be non-empty, right? Now means it should have some element in it. What's the meaning of bacha non-empty? The meaning of non-empty is that it should have some element in it. Correct, na? It cannot have nothing in it. So we have to take any 2 non-empty set, and when we are writing the Cartesian product of those 2 sets, simply written like this, you have to write bacha A comma B. What is this called as? If you remember, I'll talk about this as well. Ordered pair. You write in the form of ordered pair, where A belongs to the first set and B belongs to the second set. A belongs to the first set and B belongs to the second set. That's how it is, bacha. Okay, this is how you define Cartesian product of A cross B, and that's how you notify it. That's how you write it. Okay, symbol is A cross B. That's called as Cartesian product of 2 set A and B. Again, they have to be non-empty. Let me read the definition for you. The set of all ordered pairs A comma B such that A belongs to the set A, the first set, and B belongs to, what is B, bacha? B is the element of what, bacha? B is the A is part of basically the ordered pair. Okay, nothing but from the Cartesian product A cross B. Okay, B belongs to the set B, so B is the element of set B. Okay, called the Cartesian product of A, and that's how we notify it. This is the most important part. Okay, so I hope all of you agree, this is the most important part. This is what you have to remember all the time from here. Remember this statement all the time. A cross B is given by A comma B, the ordered pair, where A belongs to the set A and the small b belongs to the set B. Small b is the element of set B and small a is the element of set A, the first set. Okay, yes, order has to be same. If I'm writing, let's say, B cross A, na, if I write some way B comma A, okay, will it be same as A comma B? No, but it will not be same as A comma B. It will not be same unless and until B and A is equal, and so unless and until B and A are equal. If B and A are equal means this can happen. If B and A are not equal means this is not equal. Agreed, right? Very simple, not difficult at all. Just, we have to quickly revise these things because that's what is there in syllabus, and yes, questions comes on this. Questions comes on this. It's not like the question is not there. I've taken question like this, so not PYQs actually. Simple questions I've taken, but yeah, question can be framed from here. Then why to miss out on that? Right now, I'm not saying PYQs are from here. I'm saying that questions are coming from here. I can frame a question from here. It means that becomes relevant, bacha. The topic becomes relevant. If there is no question from the topic, means it is irrelevant to you right now. But why I'm saying irrelevant? Because you are having exams on your head. If you're studying something, the focus would be solving questions on the topic. If the topic doesn't give you questions only, then what is the point of studying it? Won't you all agree? Okay, but yes, question can be framed on this topic. That's why I've taken it over here and discussing and giving my time for it. Okay, chaliye, let's move on to next part, ordered pair. As I said, check this out. A and B are not always equal. If A and B is a pair of numbers, then the ordered in which the number appear is called as ordered pair. Ordered pairs A and B are different. Check this out. That's what I said, no? A comma B and B comma A are not same, provided A and B are not equal. Okay, again, if it is given like this, that A and B and C and D are equal, they're saying that A and comma B and C comma D, what is that called as? Ordered pair. If they're given as equal, it means what? It means A has to be equal to C and B has to be equal to D. A has to be equal to C and B equal to B. Same thing I said in the previous case. I said B and A has to be equal. If that is the case, means I can say they are equal. If not is equal, means this also not be equal. Agreed? Figure note bacha, A comma B, if it is equal to B comma A, it means A equal to B. Right? Second, sir, A comma, so if you're writing bacha, Cartesian product of a set with itself 3 times, so A cross A with, cross A cross A. If I have said bacha, A, B, C, ABC all belongs to, ABC all belongs to the set A. What is it called as? It's called as bacha, ordered triplet. Called as ordered triplet. Pair because 2 elements, triplet because 3 elements. Agreed? In the ordered pair, we had only 2, A comma B. So ordered pair, here ordered triplet because of ABC. Okay? Where ABC is an ordered triplet. Alright? Chaliye. Properties of Cartesian product. Let's quickly recall them. If A and B are finite sets, then number of A cross B will be bacha simply. You know this property? I have taken a question like this, so you'll solve it. Okay? Right now, in session only we have taken a question on this, we'll solve it. So number of elements in the Cartesian product of A cross B will be same as number of element of A into number of elements of B. Let's say if I have set A has 2 elements and set B has 3 elements, then number of elements in A cross B will be simply 6, sir. Simply 6. Okay, chaliye. Won't you agree? Can I show you this? I will not show you all 6, but let me just try to show you. If I have, let's say 1, 2, and I have here A, B, and C. The set is, let's say this is called set X, this set Y. Okay, how write this? 1 with A, 1 with B, and 1 with C. Correct na? Same thing I can do with 2 bacha. 2 with A, 2 with B, and 2 with C. So I have how many ordered pairs, bacha? 1, 2, 3, 4, 5, 6. Same thing I said, na? Correct? So this is what, sir? This is what, bacha? This is going to be, let's say, this is set X, set as Y. It will be X cross Y, no? This is nothing but set X cross Y. Cartesian product of the set X and Y will have total of how many elements, sir? 6. How come, sir? This is 2, this is 3. 2 into 3 is 6, sir. I just verified this property for you. N A cross B equals to NA into NB. Okay. If either A or B is an infinite set, of course they'll become bacha infinite, na? If one of them is infinite, multiply anything with infinity, what does happen? What's the result, bacha? Again, infinity only. That's why if A or B, either of them is infinity, okay, if the number of that element is infinity, then the number of element of A cross B will also be infinity only. All of you agreed? Okay. So A cross B is null. If A cross B is null, then it means bacha either this is null or this is null. Won't you agree? If I write a set A, let's see, like this. Set A is written like this, nothing. How you take intersection, bacha? Nothing only, na? So if either, if a product of, or basically Cartesian product of a set or 2 sets is coming out to be null, it means either of the set has to be null. Either of the set. Either A or B. Okay, chaliye. For any 3 sets A, B, C, we have some property, bacha. Okay, very, very important. Very, very important. Okay. Cartesian product of A with the union of B and C will be equal to A Cartesian product with B union A Cartesian product with C. I'll repeat again. Cartesian product of A with the union of B and C will be union of A Cartesian with B and B A Cartesian with C. The property is like this. Okay. You can distribute the property A cross B union B cross C. A cross C, sorry, not A B cross C, A cross C. What property is this? Distribute property, correct now? A cross B union B A cross C. All of you agree? Yes. Same goes here, bacha. A cross B intersection A cross C. Over here also same property, means Cartesian product of A with the intersection of B and C same as A cross B intersection of B A cross C. Chaliye. If I have, bacha, this is very, very important. If I have A cross B equals to B cross A, is nothing but it means A equals to B. We talked about this, right? Similar to that we talked about in the case of elements, but over here I'm saying what bacha, in the case of sets, but the property remains same. Correct now? Check here. Over here, so ordered pair is same means the elements are same thing over here. If I have Cartesian product same, it means the set is same. I'll repeat, the Cartesian product of two sets are same. It means what bacha? In the reversal order, A, B and B, A. It means the sets are actually equal. All of you agree? Let's move on to the good properties bacha. Please have a look. Again, few more properties. If A is a subset of B, then A cross A subset will be, again will be a subset of A cross B intersection B cross A. Correct now? Check this out. I can write this bacha as, what's this part? I can take A cross, okay, B intersection B, right? B intersection B. I've taken A cross B intersection B. I've taken A common. I can write it like this, of course. Okay, what happens, bacha? Check this out. It'll become A cross B. Sorry, not B cross A. A cross B. It'll become A cross B. Product of A and B. Okay, isn't this A cross A subset of A cross B? How come, sir? Because A is subset of B. Won't you all agree? I have just simplified this part in terms of this. Same way we can say if A is subset of B, then bacha A into C will be subset of B into C. So I've taken for any set C, okay, we can apply this property. A cross C means the product of A and C. What product, sir? Cartesian product of A and C will be a subset of Cartesian product of B and C. Okay, chali. For any two sets A and B, we have, sir, A cross B intersection with B cross A equals to A cross B intersection, okay, A intersection B with B intersection A, the Cartesian product. Okay, check this out. A with B intersection, okay, and multiplication with B intersection A. Again, a very important property. Very important property. Okay, now let's see the notes that we have. If A and B have n elements in common, if A and B means two sets, I'm writing bacha two set A like this, some elements are here, and set B like this, some other elements are here. How many elements are common, bacha? They have total of n elements common. They have total of n elements common. Okay, then A cross B and B cross A will have n square elements common. That's the property. If you want, you can try it out. Make a small set and try to find A cross B and B cross A and check for their common element. How many elements will be common, bacha? N square. N square, sir. Okay. Do one thing, write here three elements, make two of them common. Okay, means 1, 2, 3, 1, 2, 4. What, how many elements are common, sir? 1, 2, 1, 2. And do one thing, find the product. Find the product. What product is a Cartesian product? Okay. So I'll tell you, I will not solve it, I'll just tell you 1, 2, 3, 1, 2 and 4. Do one thing, find A cross B, okay, and find B cross A. You will find, bacha, that these will have 4 elements common. Of course, na 1, 1, 1, 2, okay, and 1, 4 is there. Same we will have 1, 1, 1, 2 like this as well. Correct, na? 2, 1, 2, 2. All of you agree? 1, 1, 1, 2. 2, 1, 2, 2. 4 elements are like this. If you're writing A cross B, from B cross A, again 1, 1, 1, 2. Again, bacha, 2, 1, 2, 2. So 4 ordered pairs will be common. That's why it means n square. I've taken 2 common, no? What is n, bacha? N is 2 here. Number of elements common, sir, 2. If you take the Cartesian product, it will become 4. 1, 1, 1, 2, 2, 1, 2, 2. Over here also. 1, 1, 1, 2, 2, 1, 2, 2. 4 elements will be common. That signifies this formula n square. Signifies the formula n square. Agreed? Please solve this. Try and solve this. Okay, let's solve this. Let me know in the comment section. Yes, sir. Agreed. Just let me know this property. Yes, sir. It will be equal to n square. It should be coming as 4. Okay. Let me know. So moving on, sir, to relations definition. If you look at, let x and y be two non-empty sets. Again, then a subset of x cross y is called a relation from x to y. it has to be having some definition, whether it can be, let's say, sum equals to 5, okay, or the difference is always 0, something like that. I can define any relation. No, means for the element x and y, for the all elements of x and y, I can define any situation like this, relation like this: sum to be equal to 5, difference to be equal to 0, the product is always even, like that. I can define bacha any relation, and then you get a pair. What is it called as? Ordered pair A comma B. Okay, this will be the element of the relation R. This will be the element of the relation R. Okay, where this is called as the domain. This is called as the image or codomain. Okay, have a look. The subset is obtained by describing a relationship. I just explained relationship can be anything, like the statement I gave: sum is 5, difference is 0, product is even, product is odd, like that. Okay, describing a relationship between the first element and the second element. Correct? Now it means, let's say, I can define b minus a is 0, b into a is odd, b plus a is 5, like that, bacha. Okay, between the first and second element of the ordered pairs in x cross y. So this will be, bacha, actually a set of, it will be element of x cross y. Okay, this ordered pair a comma b will be element of the set x cross y, x cross y. So check this out, element of the ordered pairs x cross y. The second element is called the image. Means this part, bacha, is called image of A. So B is called, bacha, what? Image of A. Remember this? We also used to call A as pre-image of B in functions, right? I explained you this when I was teaching you the PU2 part of relation function little bit. I think I explained. B is image of A and A is a pre-image of B. Okay. We have some definitions over here, very important definitions. Domain and range, the set of all first elements. All these, let's say I have like this, I have so many ordered pairs. The first ordered pair, second ordered pair, like this I have so many, okay? So all these values are called, bacha, what? Domain only. What is this called as? Domain, sir. The set consisting all these values for this relation will be called as domain of the relation. I'll repeat, the set consisting all these first element of the ordered pair will be called as domain of the relation. Domain of the relation. Okay, let me read the definition. The set of all first elements of the ordered pair in the relation R from set A to set B, okay, is called the domain of the relation R. Correct now? Okay, what is set A and set B, bacha? Where the relation is defined. How define that? A to B, relation of from set A to B. Okay, chaliye. The range, bacha, the set of all second element of the ordered pair, this part over here, is called as range, sir. Is called as range, bacha. Yes, sir, it's definition based only. What can I do about it? The chapter is like that. Okay, we'll complete it in one shot. Don't worry. I'll not, delay it. Okay, chaliye. So, the set of all second elements of the ordered pair in the relation R from set A to B again is called as range of the relation R. One more thing, what is codon, bacha? The whole set B. Whole set B. What happens now? Sometimes in a set, what will happen? I can have, let's say in set Y I'm talking about. This set B is nothing but, bacha, if you see the definition, is same as set Y. Basically I can write this to be A to B also, na? A to B also, okay? So, trying to say this, I can have a element in set B which cannot be defining this relationship. For example, I can have, let's say I'm looking for in set A, I can write it over here. Let me just erase some part. I'll explain this to you. So let me just erase this. Okay. Okay. So I'll just erase this. Okay. So I have, let's say, set A over here and set B over here. Let's say my relation is that the product is odd. The product is odd, sir. Okay. Then I can write, bacha, here 349. Okay. All right. This is going to be 2 1 7. Okay, 2 1 7. Okay, let me write this as some other odd number. Okay, I'll not write 3 4 9. I'll write some other odd number. Let's call it as maybe 5. 3 5 and 9. 3 into 1, bacha, odd. 5 into 1, bacha, odd. 9 into 1, bacha, odd. Same goes here. 3 into 7, sir, odd. 5 into 7, sir, odd. 9 into 7, sir, odd. So if my relation is that the product is odd, what is the relation, bacha? The relation is product is odd. Product is odd. So I can make the ordered pair What bacha? 3, 1, 3, 5, 1, 5, 7. Again same, I can go with bacha 3, 7. Sorry, 3, 1, 5, 1 and 9, 1. I can write again bacha 3, 7, 5, 7, 9, 7. I'll get what much total of 6 ordered pairs. Okay, but you can say here this 2 is the 2 a part of range. If I have to write the range over here, check this out. I'm gonna ask you to write something for me. This is okay. I'll erase this part as well. Let me just write. I'll ask you to write the value of domain range. So just try from your side first, then you cross check with my values. Do one thing, pause the video, find the domain. So list out all the domain, all the range and all the codomain. Pause the video and do it. I'm going to solve it now, then cross check. Okay. So write the domain, sir. All the elements of A. So 359, sir. 359 bacha, the curly bracket. Okay. What about the range bacha? The range will be very beautifully only 1, 7. Why only 1, 7, sir? Because bacha 2 is not coming as any image of any the number. Okay, 2 is not part of the any image. Okay, chaliye. So 2 is not going to be there. What about codomain, sir? Bacha codomain will have 2, 1, 7. That's why it said all the elements of B, the whole set B is called as codomain. Think about it. There's a difference bacha in B and the range. Range will always be a subset of codomain, but might not be always equal to codomain. I'll again repeat. Range will always be a subset of codomain, but not always will be equal to codomain. Is 1, 7 not a subset of B? Is 1, 7 not a subset of 2, 1, 7? Yes, it is subset, but not equal. Not equal all the time, right? So that's why bacha there will be some element. That's the difference between codomain and range. So I hope this you able to understand this. I think I've taught you this in relation function already when I was teaching you in PU 2 part, but still this is going to be very, very important. I've explained it over here as well. So let me know whether you have doubt in this part as well. Comment section, let me know, sir. Domain and range is clear. Okay, moving on to the relations part. The total number of relations that can be defined from set A to set B is the number of possible subset of A and B. And how you write that bacha? 2 power P and Q. 2 power PQ. NA is P, this is NB, sir. Number of elements in B is Q. Then total number of relations bacha will be 2 power PQ. How much is that? What is that called as? Simply number of possible subsets. 2 power PQ. So whether they write this total number of relations or they write bacha total number of possible subsets, same thing will be there, 2 power PQ. Okay, chaliye. Next, sir, note a relation R from A to A is read as relation on A or relation in A. Okay, relation A to A. I mean this. So relation A to A can be read as relation on A on relation in A. Okay, chaliye. A range is always, I explained you this right now, range is always a subset of codomain. It might be equal at that time, but always a subset. Okay, chaliye. Now bacha we are moving to functions, sir, the fun part. All the definitions are over. We'll move on to some graphs, we'll have some fun. Okay, one more thing, all the relations, okay, sorry, all the functions are relation bacha. All the functions are a relation. If there's a function, let's say fx, it'll always be a relation bacha. But all the relations are not always functions. How come? Let's see. So we have let A and B be two non-empty sets. A correspondence between the elements of A and B is called a function. What it means bacha basically? It means relation only, no? A relation between the elements of A and B is called as function from A to B if for each element of A, there exists only one element in the set B. Element in the set B. That's the definition. That's the difference between the relation and function. Okay, means so correspondence is basically relation. Okay, so I can have only one unique image of a element in set A. Okay, a function is also named as map. Okay, we call it mapping between two domain, so like two sets. So map, okay, a mapping, a function from set A to B is denoted by this format, f from A to B. Same thing, right? We used to write R for A to B, same way. Okay, the set A is known as domain of F and set B is called as codomain. I don't think you have doubt in this part. I've already explained the same thing in the relation section. All set of all F images of A is known as range. Correct na? I said na functions images, right? Correct bacha? I explained this. What is the meaning of this? So let's say I have this set A and this is bacha set B. What is it called as? These are the pre-images. Okay, 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 and these are called bacha images. What is this called as? Images, sir. These elements are called as images of the elements of set A. Nothing but range, sir. Nothing but range, sir. Range. What about this bacha? Let's say element is left. If you include that also, it will become codomain. Only images, if you make a set of only image of the element of domain, I'll repeat, if you make a set of only images of the element from the domain, it'll make bacha range. It'll make range, but the entire set B will be codomain. Range is a subset of codomain. Chali. So what I'm getting now, last part, how to define the function? So range will be equal to fx. Okay, okay, range of fx is x belongs to A. Range of function is subset of a codomain. Explain this part as well. Let's move on to the functions now. A function is always a relation, but a relation is not always a function. I explained to this part as well. All functions are relation, but not all relations are functions. This is a condition defined. I explained you right now the definition. Some important functions, very, very important. Not only for the chapter's point of view, because since it is a PU1 chapter, now what happens is, I have gone with the weightage category because we had less time. So I first did your weightage, high weightage chapter for KCET series, which was again very, very important for your boards and for your KCET. But if you were actually in PU1, this is very important, right? Because everything that you've learned from there is based upon these functions graphs only, no? These conditions of definition of a function. For example, we have identity function, we have modulus function, signum functions, whatever it is. We have learned that, bacha. If you have learned this, then only you will be able to solve the other questions. So that's why whenever I've taught you those important topics, I explain you the functions at the same time as well. So I'm gonna quickly go through this. Don't have to put so much effort right now, because already I have discussed these functions with you in detail, right? Chaliye. So first function, identity function, bacha, what happens is the x and y will be same. The x and y, basically the elements of the domain and codomain will be equal, will be same. So have a look. A function f r2r is said to be identity function if f associates with every element of set R with itself. Okay. Thus f r2r is an identity function. It will be coming like a line passing through the origin with equal inclination on both x and y axis. It's called as identity function. What it means, bacha? It means the element, if y is element from the codomain, will be equal to the element from the domain. So y equal to x. All of you agree? Simple, right? I can move on? Yes, sir. Constant function, bacha, what happens over here? For any value in the domain, will have only one value in the codomain. Okay, so we'll have only one value, which is nothing but y equals to c. So regardless of any value of x, what is y value? Always a c. That's called as constant function. It's a constant function. Have a look. Okay. Okay. So same thing written over here in definition also. I can skip this part. Polynomial function, bacha. Have a look. We write this. No, we write this variables to the power 1, 2, 3 like this. Correct, na? It can be written in terms of linear function, in terms of quadratic, cubic, biquadratic, like that. We keep going on. What is this called as? A naught, A1, A0, A1, A2 till AN is called as coefficients of the variable term, right? So this all, bacha, are going to be all real numbers, and they are called as coefficients. What is this going to be? A0, A1, A2, A3 till AN will be equal to, bacha, constant numbers, the real numbers, and called as coefficients. I hope this is clear. Okay. So we write in this format. It can be not always plus sign. It can be negative sign also. This can be negative sign because I've mentioned here real numbers. No, can real numbers not be negative? Can be negative, right? Okay. The rational function, sir, it will be in this form, bacha, fx by gx. Okay, where gx is not equal to 0. How come, sir? It will become undefined. Gx is not equal to 0. Not equal to 0. And what is fx and gx? They are polynomial functions. They are polynomial functions of x. In this form, if writing two polynomial function, provided that gx is not equal to 0, it will take a form of rational functions. We have seen this kind of function. Okay, chaliye. Modulus function of which what happens is it will have the range will always be only positive. Modulus function, sir, remember this, always positive range. Think about it. Okay, sir, this is negative, sir. No, bacha, this is not negative. Check this here. X is negative. X negative means, sir, minus x is positive, bacha. Won't you agree? X is negative, sir. It means minus x is positive, sir. Correct, na? So the range will always be coming as positive, bacha. So y will always be non-negative. It can be 0 to infinity. 0 to infinity, so this is a square bracket. 0 to infinity. Check this out. From 0 to infinity. Okay. So range is all non-negative numbers, not just positive. Even 0 is there. So that's why all non-negative real numbers will be your range. What is the code? What is the domain, bacha? All real numbers. From all x negative to positive will be there. So what is the domain, sir? Domain, bacha, will be all real, sir. Here, all real, sir. Greater than 0, x. Less than 0, minus x. Why minus x? To make the function positive. To make the function outcome positive. Please have a look. Let's move on to signum function. We define it like this: mod x by x and 0. Mod x by x in 0. So we have not learned this way. You have learned this way, right? You have learned this way. Correct, na? For any positive value of x, it will be always 1. Any negative value of x will be always, what do you call, minus 1. And for 0 will be 0, bacha. For x equals to 0, it will be 0. For all positive value, it will be coming as 1. For all negative value, excuse me, I said negative, right? It will be coming as, bacha, negative 1 or minus 1. Okay, check this out. All negative value, all real numbers on the negative side. Y value is minus 1, over here plus 1. So what is my range, bacha? What is my range, sir? Simply, bacha, 0, minus 1 and 1. What about domain, sir? All real numbers. Domain is all real numbers. Why defined like this? Mod x by x. This will make the positive number, no? This will be a positive number. What happens here? If x is negative, it will become negative. Think about it. Mod x by x, bacha. If I take x as 2, what happens? 2 by 2, how much is that? 1. Let's take, bacha, x as minus 2. What happens? Let's take x as minus 2. Let's see what happens. It will become minus 2 mod by minus 2. How much is that? 2 by minus 2. How much is that? Simply minus 1. Simply minus 1. Okay, that's how the function is defined. When x is not equal to 0, when it's 0, 0 means, when x is 0 means, it will always be 0, bacha. Always be 0, sir. So signum function. Clear? Graph is clear? This part is clear. Let's move on to next function. GIF, greatest integer function, also called a step function, right? What happens is, we have steps like this. It will be again open at all the integral values, correct now? So what happens here, bacha, is, if you approach, okay, if you approach any integer, okay, from the left side, what will happen? The result will be, bacha, it will be simply, the y will become, I can write like this. I can write like this. One second. If you're approaching the function from the left side, z minus, actually, it's not 2, it's z minus. I can write integer as, let's say, okay, z only, I'll write z minus, any integer. It can be 3, 4, minus 3, anything. From the left, what happens, bacha? The answer would be z minus 1. If you try to go reach 1 before 0, like, you know, from the left side, what is the answer? 0. What is that going to be? 1 minus 1. I'll repeat. If I'm trying to approach this number 1 from the left side, what is the answer, bacha? It'll be z minus 1. What about this? Z plus, it'll be, bacha, z plus 1. That's how I define the function. Z plus 1. Let's think about the number 3. Before 3, sir, what is the answer? Before 3, bacha. Before 3, it's 2. After 3, bacha, it'll be 3 only. After 3, it'll be 3 only, sorry. Not z plus 1, it'll be 3 only. Simply z. Okay? Chaliye. So it's talking about the next, you know, not like z plus 1, z plus means all the positive values. Next, nearby values, okay? In the nearby values only, okay? So that's how you define it. What is the, bacha, range over here? Think about it. What's the range, bacha, here? Range is only integers. Positive and negative, both are true. What about domain, sir? Domain, bacha, is already all real. Domain is all real, sir. Domain is all real numbers and range is only integers. Okay, clear, right? This part is okay. Before number, if you take, bacha, it will happen what? It will be z minus 1. Whatever number is, let's take 5. A number before 5. If you put, you know, 5, a number before 5 or in the integer, basically I'm asking you to prove this. 4 point, let's say 999 you put. What happens? What is the answer, sir? 4, bacha. So what happened? it will become minus 1. No, that's why I'm saying before number will become minus 1. So 4, if you put here 5.01, what's the answer bacha? Simply 5. Correct now? Simply 5. Okay, Shali, let's move on to next function that we have. Exponential function, sir. What happens over here? We have two graphs. One where with x increase, what happens? The function is also increasing. When x is increasing, the function y is also increasing, and this is reverse. When x is increasing, function y value is decreasing. Difference is, sir, the a value. Over here, sir, a is more than 1. What is a, bacha? The base. Y equal to a par x is there. No, this base I'm talking about. When a is greater than 1, it will be increasing function. When a is between 1 and 0, it will be decreasing in nature. This type of graph. Okay, so there's a difference. A can't be negative, bacha. A can't be negative, so okay, that's the graph says. Again, what is the range, bacha? Range is all positive, domain all real. Think about it. Domain is, sir, all real, and range, sir, only r plus. Will it be 0? No, sir, it will never be 0 also. It can never reach 0. Can it reach ever 0? No, sir, it can never reach 0. Here also never reach 0. So r, the range is always only r positive, only positive real numbers. Check here. Positive means 0 to infinity. 0 is open, sir, not close. 0 is open. Okay, please have a look. Chali. Okay, a is positive and a can never be equal to 1. That's the condition, right? That's how we define the exponential function. A can never be equal to 1, bacha. I hope you agree. Okay, a can never be equal to 1, sir. Chali. Why it is 0, 1, sir? Because if you put exponent power as anything as 0, let's say a power 0, how much is that, bacha? Always 1, no? Anything to power 0 is always 1. That's why 1, 0, 1 is here, and here also 0, 1 is there. That's not a doubt, but I just wanted to explain you. Let's move on to square root function. Have a look. Have you seen this kind of graph? Yes, of course, parabolic graph. When you join this, what happens there? You have this also with you. You have this also with you, y plus minus root x. But I've taken over here only positive side. Yes, I've taken over here only positive side. Y equal to only positive x we want, not this one. Only this part. Y equal to only positive of root x. Okay. Then you take this. What happens, bacha? X can be only positive. And what is the root? So basically your domain is what, bacha? Your domain is 0 to infinity, only positive, and range also same thing, sir. 0 to infinity, only positive. Why only positive, bacha? Because taken only positive sign over here. If you take this also into account, the graph over here, like this, then I can take negative as well, right? So, but for this function, I'm taking only positive. That's why range is also positive and domain is also positive. Clear? Let's move on to logs now. Log graphs, sir. Two things to remember over here. First of all, again the same condition will happen with the base. How did I log first? Log, bacha. Log of a function, any variable x with the base a. Okay. This base a can never be equal to 1. Okay. This base a has to be always positive, and domain is always, bacha, positive. The domain of log is always, sir, positive, not non-negative. Always positive. Log 0 doesn't define. Log 0 is not defined, sir. We don't have x greater than equal to 0. We don't have this. X greater than equal to 0 is not like this. Always x greater than 0. Means only positive numbers you can feed in log, sir. Okay, check this out. When we have a greater than 1, the log is increasing in nature. When you have a between 1 and 0, the log is decreasing in nature. But always on the positive side of the y-axis. Okay, sorry, x-axis. Only the positive side of x-axis, bacha. The graph is passing from 1, 0 because log 1 is 0. You know this? Any base you take, log 1 is always 0, bacha. Please have a look. Domain is r plus. What is the range, bacha? All real numbers. Range is all real. Check this out. Doesn't it make sense? We have learned it. Now we have learned it. Inverse trigonometric function when we learned. Log and exponential function are inverse to each other. Domain is r plus, range is r. Check this out. Range is r plus, domain is r. Inverted, no? Domain is r plus here. Their range was r plus. Their range was r plus and domain was what do you call, r. Check this out. Domain was r and range was r plus. Here just opposite. Range is r and domain is r plus. Clear? Let's solve the questions now. Okay. First question, if A cross B equals to P comma Q and P comma R, M comma Q, M comma R, then sets A and B are. So bacha, P is the element of set A and M also is the element of set A, means P and M has to belong to set A and Q and R has to belong to set B. So P, M and Q R, option A is correct. Correct, na? Option A is correct. Think about it. If I had set A as P comma M and set B as Q comma R, what we can write, bacha? PQ, PR, PQ, PR, MQ, MR. Same thing written over here. If you write this, no? A cross B, what you can write? PQ, PR and so on, MQ and MR. Right? So this is clear. Question number 2 now. If A is 8, 9, 10 and B is 1, 2, 3, 4, 5, then find the number of elements in A into B. Okay, this is the same thing, right, bacha? So NA into NA into NB will be equal to, bacha, this NA into B. How much is NA, sir? 3. So 3 into 3. NB, sir, 1, 2, 3, 4, 5. So 5. I'm getting here 9 5s are 45. So answer is 45. Option B is correct. Just taught you this. I told you I'm taking a question like this on the property. NA cross B was equal to NA into NB. We have 3 here. So I've written here NA cross A into B will be NA into NB. So answer is 45. Option B. If two sets A and B have 16 elements in common between them, find the number of elements common in the sets. Alright, this we know, right? It was this formula n square, right? Where what is n, bacha? N is 16 over here. What is n value? 16. What is the answer going to be? N square means 16 square. So 2 power 4, power 2, 2 power 8. 16 is 2 power 4, no? We are looking for powers of 2, right? So 4 into 2 will become, bacha, what? Power rule. You have to multiply 4 into 2, 8. Option A is correct. Simple enough. Very simple. Not difficult at all. Simple problems, right? Chaliye, but property based. If you don't know the property, then very difficult. You can't get it right. You lose 1 marks. As I said, no, chapters of PU1 are very simpler. Just stick to the concepts and formulas. You'll get the answers for sure. And you'll get the right answers for sure. Question number 4. Find the values of A and B if 4A minus 2. This is the property of ordered pair, sir. This has to be equal to this, equation 1. This has to be equal to equation B, equation 2 variables. 4A minus 2 equals to 3A minus 1. Bring this 3 over here and this minus 2 over there. I get 4A minus 3A equals to minus 1 plus 2. So I get here, oh, very simple, A equals to 1. The next one, bacha, B plus 4 equals to 5. Why, sir? The property A comma B equals to A comma B or C comma D. When A is equals to C and this property, sir. A comma B equals to C comma D when A equals to C and B equals to D. Same thing I'm using over here. B plus 4 equals to 5. B equals to 1. A is 1, B is 1. A is 1, B is 1. Option C only is right. A is 1, B is 1. Rest all we have negative sign as well. So option C is correct. A is 1, B is 1. Please check. Please check. A is 1, B is 1. Okay. Moving on to question number 5. Let A, B, C, D and B, X, Y, Z. Which one of the following is not a relation from A to B? This is there. This also is A to B. This also is. This isn't. Check this out. D comma A coming from the same element. I am looking for, bacha, relation from A to B, right? 1 second. Relation from A to B, right? A to B. Then I can't write no D comma A. This has to be, bacha, coming from this element has to be from the set B, right? This A does not belong to set B. The A here does not belong to set B, does it? Check this out. We have X, Y, Z. It means incorrect. A does not belong to set B. It means our incorrect option, which is not a relation of A to B, is D. Clear, right? Not a confusion. They're looking for an answer which is not a set of, not a relation from A to B. So first three are, the last one is not. Please have a look. If a relation R is defined on the set Z of integers as a comma b equals to belongs to R, a square plus b square is 25, then domain of R, okay. Check this out. I can write this as b square equals to 25 minus a square. So b equals to root of 25, okay, 25 plus, okay, minus a square. We'll have a plus minus sign over here, okay. Domain, what can I take, sir? I can take 0. Yes, I can take 0. If I take 0, what will happen? It will become plus minus 5. Check this out. Plus minus is there. It will become 25 minus 0. What's the answer, bacha? Root 25. So root plus minus 5. That's okay. Correct, na? Why okay, sir? Because bacha, this is defined on set of integers. This is correct, no? Plus minus 5 is both set of integers, right? Plus 5 is integer, minus 5 is also integer. So 0 is okay. We have, sir, 3 also. We have 3 as well. So let's take 3 over here. If I take a as 3, what will happen? 25 minus 9, 16, plus minus 4. If I take a as 3, or plus 3 or minus 3, I can take anything, no? Whether I take plus 3 or minus 3, it will become the same thing, right? The square of that will be always 9 only. If I take a as plus minus 3, what is bacha? This will become, b will become plus minus 25 minus 9 only, na? How come 9, sir? Square of plus 3, 9. Square of minus 3, 9. What is the answer, bacha? Plus minus 4. Correct? So this is also an integer. It means b plus minus a plus minus 3 is also okay. A 0 is also okay. This is bacha when a is 0. Same thing if you do with a plus minus 4. What will happen? It will become 16 minus 16. So 9. 25 minus 16, sir. How much is that? 9. Plus minus 3 is also okay. Plus 3 is integer. Minus 3 is also integer. Now take bacha plus minus 5. It will become 25. This part will become 25, which is 0. 0 is also integer. Okay. It means our option is C. I hope you got it. I'm replacing this a with 0, plus minus 3, plus minus 4, and plus minus 5. I'm getting the result. Whatever the result I'm getting, that has to be an integer. How come, sir? That's what the set is defined for. Okay. If it is coming as integer, means the respective a value is correct, is suitable. Okay. It means 0 plus minus 3 plus minus 4 and plus minus 5 is the suitable value for the domain of the relation R. All of you agree? Option C is correct. Let's move on to question number 7. Let R be the relation on N defined as x or y if x plus 4y equal to 16. Okay. So I can take 4 as x. Let's see. I take 4 as x. What I have? X plus 4y equals 16. Take it, bacha, x as 4. 4 plus, what will happen to this? 3, na? 4 is 12. So y is also 3. If I take x as 4, y will come out to be 3. Correct? 4 plus 12 is 16. That's correct. Because bacha, they are saying that it should be on natural number. Means y also has to be a natural number. Y has to be a natural number. This is suitable. Let's take, sir, x as 8. X as 8 we are taking. When I take x as 8, bacha, what happens over here is, I can write this as x as 8 means y has to be 2. 8 plus 8, 16. This also is correct. Why, sir? Because x and y both has to be natural number. Agreed. Let's take now x as 6. What is the value of y, bacha? X 6 means this is going to become 4 by is 10. X is 6, right? Bring this over here. It becomes 16 minus 6, so 10. So y become equal to 10 by 4, which is not a natural number. Not equal to natural number. It means not possible. When I take x as 6, y is coming as 10 by 4. Not a natural number, right? But y also has to be a natural number. It means this option is ruled out. Okay. What about bacha 12? Let's take x as 12. X as 12 if I take, yeah, then y will be 1, sir. Y is 1, sir. X is 12 means 12 plus 4. Or here, 12 plus 4, 16, so y is 1. This is also a natural number, correct? Now let's take x as 1. To check the option number D. X is 1, sir. What happens to this? 4y is 15, no? 4y equals to 15, right? X is 1, bring it over here. 16 minus 1 is how much, bacha? 15. So y equals to 15 by 4, which is not equal to natural number. It means this also option is incorrect. So option B and D are incorrect. Okay, option A and C both can be right. Which is the better answer, bacha? Okay, the domain, we have to write for the full domain only, right? So option C is correct. We are getting here out of the given options 4, 8 and 12 is giving me the natural numbers as y. Please check it out. B, D is incorrect. A is correct, but 12 is missing in that. But write all the domain, right? All the elements in domain. So that's why option number C. You have to check for all of them. Okay, simple only, not difficult, right? Let's move on to question number 8. Okay, let A equals to minus 1, 1, B equals to minus 1, 1, C equals to 0 to infinity. That relation R is defined like this, and R2 defined like, okay, R1 is defined from, R1 is defined, bacha, from A to B, where R2 is defined from, excuse me, A to C, I think, yeah. R2 is from A to C, R1 is A to B. Okay, let's solve. Let us solve it over here. So for the first one, x square plus y square equal to 1. It means y square equals to root of, okay, no, not root. 1 second, simply 1 minus x square, no? 1 minus x square, right? Not the root. Now the root part will come. Y equals to root of 1 minus x square. Okay. Now x value, bacha, have a look. X value is, sir, from minus 1 to 1. How come, sir? Check this out. X belongs to, bacha, A, na? X belongs to A, sir. The first set. Okay. So minus 1 to 1, I can take any value between minus 1 to 1. Let's take 0. Let's take, bacha, x as 0. I'm getting y as root of 1. If you take root, bacha, what will happen? The answer will be, sir, both plus minus. Both plus minus. Okay. Correct. It means for one value, I'm getting, bacha, here answer as 0, 1 and 0, minus 1. But a relation can be a function only if, for each element of x or the domain, there should be only one image. But I'm getting for 0, if I, let's say this is my set A, this is my set B. For 0, I'm getting two answers. From 0 to 1 and 0 to minus 1. This is not a function. We are getting for same value of from the domain, two different answers of in the range. Okay, it means not a function. This is, sir, not a function. R1 is not a function. Let's check for R2. Let's check for R2, bacha. 1 second. For R2, sir, what will happen? Same thing will remain. So y square equals to 1 minus x square. Same thing is this. Y equal to root of 1 minus x square. This is also same. Domain is same, sir. Domain is from minus 1 to 1 only. I can put x equal to 0 again. What happens to y? Y is coming as root of 1. How much is that? Only plus 1. Why only plus 1, sir? Why not minus 1? Why not minus 1, sir? Check the range. C value. 0 to infinity is there. I can't take negative value in that. Why, bacha? Because y value is coming from B, right? When coming from B means it becomes plus minus 1 both. I have the answer minus 1 to 1. So I can write, bacha, both plus minus 1. But when I'm taking this relation R2, which is defined from A to C, sir. A to C means y is coming from the C, the set C. Set C doesn't have a negative value, right? The element y is of set C, and set C doesn't have a negative value. It's a positive value. It means I can't take negative of minus 1. Means that for x equal to 0, I have only one answer, y equal to 1. It means we have only one ordered pair, sir. 0, 1, which is a unique ordered pair. It means that, bacha, what? It means that is going to be a function. So answer is R2 defines a function from A to C. Got it? It's a very, very good question. R2 is a function, but R1 is not a function, because we are getting two different images of the same element in domain. Whereas in this case, for element A, for the set A, and for set C, which I am getting unique values. For 0, I am getting only one value, which is 1, not minus 1. Why is that? Because C is not a negative number. C doesn't have a negative value in it. Only positive numbers and 0. Please check. Excellent question. Very, very good question. Okay. Have a doubt? Let me know in the comment section. I'll move on with the questions. Question number 9 now. Yes. If the domain of the function fx equals to x square minus 6x plus 7 is this, then the range. Can you factorize this, sir? We can't factorize it. We can't factorize this. So we can't solve it like that. We're looking for range, right? Right, y equals to. What we can do here, bacha, is very interesting here. Check this out. I have x square term. I have 2ab term. How come, sir? 2 into 3 into x. Correct? So I can make perfect square. X square minus 2 times of 3 times of x. It means what is b value? 3 square. B square is 3 square. Adding extra means subtract extra. Correct na, sir? I need the 3 square to make perfect square, sir. My requirement, I cannot just add anything. I have to remove that. So minus 3 square plus 7 because given in the question. It makes x minus 3 the whole square plus 2. Sorry, minus 2. Excuse me. My mistake. Minus 2, sir. Why minus 2, sir? Minus 3 square bacha is minus 9 plus 7. Minus 9 plus 7. Minus 9 plus 7 is minus 2. Yes. Bring this value over here. We are looking for bacha range, right? Okay. So bring this value over here. It becomes y plus 2 equals to x minus 3 the whole square. So I can get this as x minus 3 equals to root of y plus 2. Think about it. Can this root be negative? This is the real part. This is the imaginary is going to become. If I take y as negative, it means very simply, sir, y plus 2 has to be always greater than or equal to 0. Greater than or equal to 0, sir. It means, bacha, what? Y has to be greater than or equal to minus 2. Right, sir? It means, bacha, minus 2 to infinity. Simple. Again, excellent question. A very good question. Answer is option A. But is it difficult, sir? Excellent question, but difficult, sir? Not difficult. Not difficult at all. Excellent question, but not difficult at all. Okay. Question number 9A. Option is A. Please check. How did I get this? I'm looking for the constant on y. How come, sir? We're looking for range, right? So that's why we got the root part over here. Constraint on y. What is that? Greater than always equal to minus 2. Greater than equal to always minus 2. It means greater than minus 2 means minus 2 to infinity. Option A is correct. Moving on to question number 10. If fx equals to, if f of x plus 1 by x equals to x square plus 1 by x square minus 1, then find the value of f of x. This is a very simple question. If you understand the concept of the functions properly, know this, I can replace any function. If let's say I have fx equals to e power x, can I not write this as f of t equals to e power t? Right? What I'm trying to mean is, if I can somewhat make this into a function where I can exchange the variables, replace the variables, it'll make my life easier or not. Think about it. I can change the variables directly, bacha. Once I'm able to do what? Able to make this in terms of x plus 1 by x. This whole thing. Which I can do that because I have, sir, a square, b square. All I need is minus 2ab or plus 2ab. Okay, let's have a look. I need plus 2ab because I have x plus 1 by x. So I can write this as, have a look, f of x plus 1 by x equals to, bacha, just part over here, x square plus 1 by x square. I'm going to add here 2, subtract 2 and minus 1. Why, sir? Think about it. I have x plus 1 by x, no? I want to make this whole thing in terms of x plus 1 by x so that I can replace the entire variable. Because, bacha, I cannot just replace x, na? Think about it. Can I replace only x? No, sir. I have to replace the whole thing, right? I'm replacing this whole thing by t. Correct, na? So I have to make this whole thing in terms of that. See here, x became t, sir. Agreed? Okay. So I can replace this whole thing by another variable. Okay. For that I have to need that same part over here. Okay. I have a square, x square. I have b square, 1 by x square. I need, sir, plus 2 or minus 2. Plus 2 I need, sir, because, bacha, I have to make plus whole square, na? Combine these three together. Adding plus 2 means I have to remove that minus 2 as well. So that's why minus 2, minus 1. Minus 1 is given in the question. Okay. It becomes x plus 1 by x the whole square. First, this 3 terms. Minus 3. Okay. See the magic now. What I'm getting now? f of x plus 1 by x equals to x plus 1 by x the whole square minus 3. Sir, I can write the variable anything. So simply take bacha x plus 1 by x as t, sir. This will become bacha f of t equals to, how much is that, sir? T square minus 3. Sir, I can write t as x also, na, sir. I can write t as x also, na, sir. Write it. It will become, sir, f of x equals to x square minus 3. Sir, why not here only? You can write here only. If you want, you can write here directly. X plus 1 by x equals to x. I'll tell you what. What you can do here is, write this here directly. X plus 1 by x equals to x. Sir, x and x is cancelled. Don't have this confusion, okay? We are not doing this equal to, we are actually replacing the variable, sir. That's why, I removed this part. That's why I removed this whole thing with another variable t to get rid of any confusion as such. Because a lot of students are watching me, okay? They should not be having this doubt. Why sir did that, okay? So what I did, bacha, over here is, I didn't want to have that confusion, x and x is cancelled, sir. That's why, actually what we're doing here is, replacing this x plus 1 by x is, x as x, okay? So what we can do instead is, replace with another variable t, get the function in terms of t, and write that again, t in terms of x. That makes sense? Whichever is easier for you, use that. Whether this format is okay, x plus 1 by x is x, then write directly this from here to here. If not okay, then bacha use t and get a bridge. Your choice of answers. Answer is bacha C option. Option C, sir. Okay, I hope this is clear. Moving on to question number 11 now. Find the domain and range of the function fx equals to 2x square minus 1. चलिए कर लेते हैं. Domain and range, sir. Y equals to 2x square minus 1, sir. Life is so difficult. अरे बच्चा, x value all real. X is all real. Domain is all real. How come, sir? What you can put for x value? Sir, I don't know. I can put negative also. I can put positive also. I can put 0 also. All real. X is all real means all the options are like that only. Okay. X is all real. What about y, sir? Do one thing. Make x a subject. See the life change. Y plus 1 equals to 2x square, sir. So y plus 1 by 2 equals to x square, sir. It means x equals to, sir, root of y plus 1 by 2. Easy, sir. This has to be positive, sir. Yes, sir. Y plus 1 by 2 has to be always positive, na, sir. 0 or positive. 0 can be true, but positive at least. Okay. It means, sir, y plus 1 should be greater than 0, sir. How come, sir? 2 is there. Cross multiply. Positive number. I can multiply, no? Think about it. It's a very good point that I can discuss over here. Positive 2, cross multiply. Can I multiply if it was negative 2? If it was equals to minus 2 over here, can I multiply? No. If I'm multiplying, let's say I had y plus 1 by minus 2 greater than equal to 0. What happens if I multiply, sir? It will become y plus 1 less than equal to 0, bacha. Negative number multiplying with other side makes the inequality reversed. I have taught you that, okay? So we can't do it over here directly. We have to make this rule useful. Otherwise over here we can do it. Why, sir? Positive number. Innocent positive number, not a problem. Innocent positive number, sir. 2 is innocent positive number, bacha. It means cross multiply. Okay. What I'm getting, sir? Y greater than equal to minus 1, na, sir. It means, sir, minus 1 to infinity, na, sir. Close here, close here, open here. Infinity always open. Forgive me. Open here, close here. Minus 1 to infinity. Option number B is correct, sir. Option number B is correct, sir. Domain is all real. Domain is all real. And range is minus 1 to infinity. Check this out. Please check. Please check. I hope this is clear. This is just a note, bacha. Just a note. Not relevant to this particular question. Not relevant to this question. Just a note. Why, sir? If you have a negative number over here, multiplying with inequality, reverse the inequality. Reverse the inequality. Question number 11 is done. I'm going to move on to question number 12 now. Quickly, we'll solve question number 12 and then we'll move on to 13th. For real values of x, then range. Okay. For real values of x. Okay. What's the range of that? Alright. Y equals to, interesting question, sir. Very interesting question. I'll tell you why interesting. Because looking at this question, what will happen? No, you'll have urge to write it this in terms of x plus 1 the whole square, x minus 1 the whole square. No, we can't do that. There's a minus sign over here, so we can't do that. What we can do is then you're gonna write it this as plus 1 minus 1. Then we can do, sir, x plus 1 the whole square by x plus 1 the whole square minus 2. Again, not useful. Why do that? Okay, I know this. You will have this urge only to make perfect square to make some more sense to the question. But check the statement first. They asking bacha real values of x. For x to be real, find the value of y. I'll repeat. For x to be real, find the value of y. Y, sir. Range is what, sir? Y only, na, sir. I'll repeat. For all values, real values of x, find y, sir. How can x be real, sir? We have learned only one way. What is it? Quadratic equation. Let's solve it. Cross multiply. Y times of x square plus 2x minus 1 equal to x square plus 2x plus 1. Yes, sir, making sense now. Sir, if I make a quadratic equation in x, I'll repeat, if I make a quadratic equation in terms of x, sir, then I can check the real roots of x, right? And from there I might have something, because I'm looking for real values of x, sir. If real values of x gives me some values of y, it means my answer is correct, na, sir? When I'm looking for real values of x and I'm getting some result in y, my life is simpler. Real value of x, sir, real value of x, sir, for quadratic equation, discriminant is always equal to 0, sir. For real value of x, the discriminant of a quadratic equation has to be always non-negative. Non-negative means positive or 0. कर लेते हैं. Write the x square coefficient, बच्चा. Here I have y, here I have 1. So y minus 1. Sir, difficult. Arey, y into x square. Here what I have? Only x square. Taking x square common. Y left here. Nothing means 1 left here. So minus 1. Y minus 1. Bringing this on this side makes minus 1. Simple. Next, bacha. Plus, sir, x times of. What is there over here, bacha? 2 into y. So, sir, 2y, sir. What about here, bacha? I have minus 2 only. Y minus 2, sir. Plus 2x. Bring here. Minus 2x. Take 2 common. Say, take x common. So, 2y minus 2. Okay, sir. Next, bacha, I have the constant term. What is it going to be? Minus y over here and minus 1 over there. So I write here minus y minus 1 equal to 0. How come, sir? Y into minus 1 is minus y. Plus 1 comes here, minus 1. Okay, agreed. Can I simplify this one step further? X square y minus 1 plus x times of 2 times of y minus 1. Okay, minus y minus 1. No, y plus 1. Y plus 1, so I'm taking minus 1 common, so y plus 1. All agreed? Okay. Let's move on now. For x, what is it happening, sir? For real values of x, bacha, what is happening? D has to be greater than equal to 0. What is D value, sir? D value is b square minus 4ac has to be greater than equal to 0. What is b square, sir? This value, sir. So means 2 times of y minus 1 the whole square minus 4 times of a y minus 1 times of c. How much is that, bacha? Minus sign is there, which makes it positive. Sir, I have a minus sign over here. 4ac minus will become positive, sir. So correct. Right here plus 1. I hope no doubt whatsoever. What I've done, minus, c was negative number, minus y plus 1. Multiply with this minus sign becomes positive, sir. Clear, na? Not a problem at all? Okay. Can I make my life easier a little bit? Take y plus 1 common, sir. Sorry, y minus 1 common, sir. Y minus 1 common, sir. What I'm getting over here? Check this out. Sir, it will become 2 square, na? So 4 times of y minus 1, sir. Why not whole square, bacha? Sir, square of 2 is 4. Square of y minus 1 is y minus 1 the whole square, sir. No. I've taken this part common. Check this out. Check this out. Y minus 1 here, y minus 1 here. I've taken it common over here. So I can't say that, sir, it is equal. Put here a whole square. I can't do that. Plus 4 times of y plus 1. Excellent problem. Please have a look. I'm going to write this in the next slide. I'm going to write it over here. Y minus 1 over here. next bracket sir, I had 4 times of y minus 1 plus 4 times of y plus 1 greater than or equal to 0. Let's cross check once. 4 times of y minus 1, 4 times of y plus 1, correct only. Expand inside. 4y minus 4 plus 4y plus 4 greater than or equal to 0. Minus 4 plus 4 is gone. So what I'm getting here, y minus 1 times of 8y greater than or equal to 0. Two options I'm getting, bacha. Two options sir, what is that? I'm getting here y equal to 0 or y equal to 1. Positive I want, right? Right? Okay. So minus infinity to 0, open, closed, union, this is 1, right? 1 to infinity. An option like this? First option is correct, sir. This is okay, right? This is okay, no? This method is okay, right? Baby curve method. Start on positive sign over here. Check the positive sign. Sign over here, sir, positive. That's my plus sign. Okay. Alternate sign, because 1 is coming only once, so alternate sign change will be there. Again, this is also coming only 1. 0 is also coming 1. So again, sign change will be there. Looking for greater than, it means plus minus plus. So plus is where, sir? Here, infinity, negative infinity to 0. And here, sir, plus infinity. So 1 to plus infinity. Answer is this, bacha. Let me know if you have a doubt in question number 12. It's a very good question. Question number 12. Option number A. I have taken time over here because I wanted to explain you a lot of things. Otherwise, you will not take this much of time to solve the question. All of you must agree with me. This is, bacha, your last question of the day. Question number 13 is the last question of the day. You had fun in the session today? Let me know in the comment section. Yes? Okay, sir. Simple chapter. We have done a lot of questions. 13 questions we have done, sir. Had fun. Okay. Chaliye. The domain of the function that means basically they're asking us the value of x, no? Correct. That's the domain, right? X is the domain. So log of 2, log of 3, and I have log of 4x. Bacha, for this log, first log to be defined, this has to be positive. How come, sir? We just learned, bacha, log cannot take a negative value, means positive, sir. Not equal to also. Positive, sir, always. Okay, sir, if you say so. Okay. So log of x to means this part. I can write this as a variable y, no? Not a problem. This value has to be always positive. I've taken here log 3 to the log of x, log x by 4 to the base 3 is always positive. Okay. What we can do here? Take exponential function on both sides. With the base 3, it will become, bacha, it will become, sir, log of x to the power of base 4 will become equal to 3 power 0. Sir, how come, sir? Log of x to the base a equals to, if I have, let's say, b. What's the formula, bacha? Remember this? X equals to a power b. Yes or no? That's the property of log exponential function. That's how we can, change them in between them. Base remains, x becomes free, and power will be b. Okay, same here. What is that going to be, sir? Log of x to the base 4 greater than 3 power 0, 1, sir. Greater than 3 power 0, 1, sir. Again, bacha, same property. X greater than 4 power 1, sir. Same property, sir. This time I'm taking with x, bacha. Taking x as it is, 4 power 1, sir. How much is that, bacha? X greater than 4, sir. Greater than 4 till what point, sir? Infinity. Answer is, bacha, 4 open to infinity. Why open, sir? Not equality sign here. Why not equality, sir? Because not equal to 0. This is same thing coming from here to here. From here to here. Not equal to 0. That's why not equal to 4. So 4 to infinity. All of you agree? Yes. Answer is option number B. I can show you over here. Take log 4 to 4. What is the answer, bacha? Log 1. This will become 1. Okay. This is 1 means log of this will become, bacha, 0. 0 means, sir, I can't define now. Correct now? If I put here 4, it will become 0, sir. This part will become 0, sir. Can I put find log for 0 value? We can't, sir. Hence undefined. That's why we can't take x as 4. We can't take x as 4. That's why x is equal to 4 is open, sir. Question number 13 is done. Good question, simple but good question. Okay, chaliye. This is it, sir. I hope you had fun in your session number 1 for PU1. Let me know your feedback in the comment section. I'll try to be more and more consistent and finish your entire portions of PU1 also on time. Okay, you know my commitment, our commitment on the channel. We are here to help you out in any way that is possible. You have seen our commitment, right? And will continue to do so. You have just be positive with us. Try to encourage us in the best way possible from your side, and will be motivated all the time to keep working hard and coming here with a value added session for all of you. Again, for free bacha. Okay, so things are going very good. I hope you are preparing very well at home. Okay, any other help you need from our side, again please put it in the comment section. We'll try to resolve it. Okay, so right now I'm gonna end the session. I have to say bye bye. Take care of yourself, keep working hard, take care, bye bye.